Well, hello, my name is Sergey Kovalchuk, and I would like to describe our empirical study in the analysis of matching test-based and metric-based evaluation in code generation with actually large language models. The motivation here is that we as our day-to-day work, we are working with language models in programming domain in different aspects in code search and code generation, one of the questions we faced is that when we consider, for example, question answering in the programming domain, we actually see problems in the evaluation of models, because in the programming domain, as actually in any complex domain, there are maybe many different answers, many different correct answers to the same question. But usually the common approach in the large language model application, training, evaluation is in considering the linguistic features, the comparison to some reference answers, and in this situation, it might be not the case, because again, we can have different, completely different answers in the linguistic structure, but they both answer the question. We can observe such a question in a Stack Overflow in many forums where the people ask for some help in different kinds. This may be the API usage or conceptual problem and coding problems, and they get answer as a code. So on the other hand, the recent development in the language models in the coding area, in the programming area, reached the point where there are a lot of tools producing the tests automatically. And with this idea, we come with our thought that we can consider these test-based metrics as a passing score or as additional metric to the language models. The specificity of our particular problem in question answering scenario is that we don't have actual codes and don't have the codes to code we can trust. So the idea is to match two generative language models. One is for generating code as an answer, and other is for generating tests. And with this idea, we've built a kind of two-side pipeline. One is for question answering with code model, code generation model, using the questions and answering scenario, mainly referring to the Stack Overflow system as an example. And we were trying to apply the common approach with prompting with a query and generation of the an application of code generation model with targeting as a common NLP metrics. And the second part of this pipeline is with test generation. And the key question we are trying to consider in this research is how we can compare the commonly applied NLP metrics and test-based metrics. And for this purpose, we again consider Stack Overflow as a main source of our examples and data set we can consider. And we use two manually curated data sets, which use Stack Overflow as original source and then adopt it. That's an APIzation, which is a bigger one, and a smaller alternative to just to see the different sources, Canal Anonymous, which is analog to a large Canal data set, which is well known, but for Python language. And we, in our test set, is focused on the Java language to be like more consistent. For example, you can see here the snippets obtained from the APIzation dataset, which refer to the original question from Stack Overflow and the answer from Stack Overflow. This is the answer, which is wrapped into the code by the author of APIzation, and we use it as a reference to perform the NLP part of our pipeline and test generation also. For code generation part, we were using several models. Mainly the most promising and most applicable to our extent was CodeGen, code generation model. Also, we compared it to GPT, one of GPT models, GPTNeo, which is more close to common natural language, not to code generation. And for the purpose of the code generation, we implement such an approach in wrapping the query into the multi-line comments and starting with a simple definition of class and a method. So the answer generated, for example, by CodeGen, you can see in the bottom right corner. Here, the blue lines of code is prompt, and the red lines are generated by CodeGen. As for the answer for this query. For test generation, we also used two solutions, namely Machinet and UTBot, which is intended to generate tests for code. And for example, in the right side of this slide, you can see the two tests generated for this code snippet. We automate the test generation using the IntelliJ IDEA and implement a small plugin to just to run the test generation and test evaluation in the IDE for all our samples in the dataset. And what we obtained initially. For the APIzation data set, we see, again, we were trying to compare the behavior of the code generation model in two kind of metrics. One is general natural language metrics. We selected two of them as more differentially focused. One is Rouge, mostly focused for natural language and text, and the second is Ruby, which is more specific to code generation. And again, we selected the code snippets and tests which both compile, and the code snippets which pass the tests with the original answer from Stack Overflow. So we've got like 800 of samples for further analysis, and what we see is that the actual metrics for both of them. For both cases where the generated test passed the code, or generated code passed the test, sorry, and generated code didn't pass the test, the metrics are rather close. For Ruby metrics, they are statistically different, but you can see that even in this case, that's really close. So we've decided to analyze deeper what were the problems and what were the issues in the test and code generation, because as a natural language models, it is expected that the models with higher metrics will pass the tests with high probability. Here's an example of the complete sample with the answer from CodeGen model and with the answer from originally Stack Overflow or from the snippets in the internet and the tests. And that's a good answer. Actually, that's the answer of CodeGen model which pass the test and which has rather good metrics. But if we see the situation in the details, we can observe that even though we see high positive correlation between the NLP metrics and passing probability for all the combinations of testing and code generation models, but even for the very low range of very low values of language metrics, we can see cases where the tests pass, and contrary, in the highest metrics, we can see cases where tests didn't pass. So for more deeper analysis, we've selected the most, let's say, contradictive subsets. We selected the cases where the generated code didn't pass the test, and it has that should be opposite. Didn't pass the test, and it has high NLP metrics. And oppositely, when it passed the test and it has low NLP metric. These signs should be opposite here. Sorry. And what we see that there are few but very interesting and important things where the test generation or code generation fails. For example, with high metrics and test failing, we can observe the different, for example, situations where the code is actually correct, but it is wrapped with different returning statement. For example, here, like the correct, the question was to get the second part of the string after splitting, and actually the generated code did the splitting, but it didn't return it. And the other case, for example, is a solution where the it is supposed to, it should return the property, system property, and the problem is that the property is different, and that's actually the common behavior to even state-of-the-art large language models, where it gives the answer which looks like a good answer, but it fails in the deeper analysis. And actually, that's a very very important part, because if we train the models, large language models with such metrics, you see they are rather high in both cases. we've got what we have. We've got the models which answers with statistically probable answers, which looks like a good answer, but might be not the good answer. The opposite case with low metrics and passing the test actually is often the case where the solution is good, but it is semantically same, but syntactically completely different. And it may, in this case, for example, it comes usually from the way of presenting the answer in Stack Overflow still. That may be the case in different situations. Because again, in programming, as in any complex domain, you can solve the problem in a different way with different approaches and different technologies. And that leads to the language structure is totally different, but both solutions solve the problem. And that's what we come with, that actually the current state-of-the-art solutions for code generation is rather good in both generating the problem-solving code and test generation, but it's not the best. It has a lot of issues, and for example, if we consider possible industrial solutions, possible complicated solutions for solving the wide range problem, we need to combine it. Because again, that's a common problem. The answer may look like a good answer, but it may not be the case. So the most promising direction here is that I think we can combine it directly in the, not only in the evaluation way, we can combine it in the model training way and in the model fine-tuning. And I believe this allows us to deeper understand the semantics of code, because at least in the contradictive situation, it may be the case where we can implement some inference, some logical reasoning about the generated code, and avoid using the weak language metrics, for example. Or in the contrast, we can avoid using tests if that's not the case for the model, for the code generation model. That's like a few insights we have. And I believe that's very important, especially in our situation in current state of the art, where there are a lot of discussion in the large language models, ChatGPT, and all these models being applied in programming domain also. We, as a developers of solutions related to artificial intelligence, should be especially careful when we are thinking of implementing the artificial intelligence-based solution in the especially generative solutions. That's it from my side. Thank you for having me here, and I'm ready to answer your questions.
Do you think it would be possible to apply metrics to the AI-generated ideas, I mean code or tests, after they generate it? Maybe not before, but after. Let's say the AI gives us something, and then we apply some metrics, and we measure whether the AI is right or maybe it's wrong. So somehow.
Yes, actually, that was the idea.
Uh-huh.
We were trying to apply the metrics on the results of the generation. We've used vanilla models just for that. We want to see what state-of-the-art solution and the industrial solution in test generation can do with the results of code generation. And with the results, we applied tests and NLP metrics. And that matching is for the results, not for the training.
Got it. Okay.
So yeah, interesting talk again. Very good. So maybe a question here is, maybe the most interesting part of your presentation would be focused on the false positives and false negatives. And by that, I mean the cases where the metrics say something and the test says opposite, right? So what have you taken a look at that to see, is there any patterns that we can learn from that?
There are a lot of them, actually, a lot of patterns we can see as a semantically important, let's say, because there are a lot of technical patterns, like, for example, the code can be correct, but it returns the result in different way. The common mistake we observed many times was when the code generates the good answer, but it is given as a console output. It is printed, but the test expects the return value.
Okay.
That's a problem of automation. But in there are also many cases where there are situations with more semantically important cases, like, for example, that's on the right. I believe that's one of the important points here, that we see here the very close to the original answer, but it is different in some parameter.
I see. Okay. Okay.
Yes, and that's an important mistake which we need to keep in mind, because that the reason for this mistake is that the model, which was trained on the public data sets and large data sets, statistically observe these parameters more frequent. And that's why it answers with this parameter, seeing like a query with directory. And the problem is very common, and there are many publications considering like ChatGPT and discussion around it, where it gives an answer, but the answer is only looking good.
Yes.
You know, my teammate collect a series of examples where the ChatGPT fails, and there was a very good examples on how to use some API in if I'm not mistaken, TensorFlow or something, and ChatGPT answer with a good looking answer. Like you can use these sort of API. Here's a reference to paper, and here's an example of API usage. But it was totally wrong. There is no such paper, there is no such API, and the code was not compilable.
Interesting.
I can confirm that. As a programmer, I tried to use ChatGPT, and before that, I tried to use this GitHub Copilot, and neither of these tools actually were useful. So they are very confident. They suggest with absolute confidence the solution, but usually when you try to get some specific result from them, like give me the code which is correct down to the very line of it, then you get something very wrong. So I'm using ChatGPT every day, but my usage scenario is different now. I'm not using it for getting the code pieces, but getting some advice. Like I'm asking, what do you think is the right way to implement that kind of, and then it gives me very abstract, very high level, but very interesting, usually very interesting response, which I can use and then go to Stack Overflow and find the specific answer. So ChatGPT is very good on the high level of abstraction, but when you go down to the level of the line of code, then that it's going to mislead you. It's going to give you something which you spend more time even. And I'm not sure whether they will be able to fix that in the future. And I can give you maybe one more example, take your time. So we're developing some custom programming language, which nobody uses, like a very internal local language, which we use for our own purposes. And when I was using Copilot, so I installed it into IntelliJ, and I was editing my code in my own language. So this Copilot never saw that language on internet. It was a completely new language for the machine. And all the machine saw was just a few files with this language and maybe a few hundred lines of code. And it started to suggest me how to write the code in my programming language. And the suggestions were syntactically correct, but semantically absolutely wrong. So it just grasped the idea of the syntax. It was giving me the correct indentation, correct names. Like it looked really like something which I would accept if I would not understand the semantic. But I knew what I was doing, and I was like rejecting that because it looked to me like a programmer sitting next to me, having no idea of what's going on, but giving me suggestions every minute, like write code this way, write code that way. So what you do, you just shut up that guy and just remove. So I uninstalled that. I don't want to give like a bad impression to anybody. The Copilot maybe in the future is an interesting product, but so far this is my experience. If you expect some specific code from these tools, you're going to be very disappointed at this moment of time. Maybe in some time something will change. I don't know. Just
to quick wrap on what you said, because I was on a panel yesterday with people from statistics, people from AI, people from geology. They were using ChatGPT, and they come up with, interestingly, the opposite thing. They said ChatGPT is bad at the high level and good at the low level mappings. What they call them low level mappings means the small atomic tasks, but it's very bad at the high level representation of things. So it's interesting because different domains have different opinions about it. And this is the beauty of this topic, you know.
Maybe the issue is that we have not 2 levels, but 3 levels. And when they are talking about the ChatGPT is good in the lower level, they are talking about 2 lower levels. And if we are talking that ChatGPT is good on the high levels, we are talking about 2 higher levels, and it is bad on the middle level. It is good in the very tiny, like correcting syntactic structure of program. I think.
Yeah, that's what they call by low level. This is the low level.
It's good in discussion the abstract ideas because they are in between you two, but they are bad in the matching it.
Okay.